Everyone. Thanks for having me here. My name is Amir Sadeghpour. I'm an associate professor of soil fertility at SIU, and today I'm going to update you on one of our NREC projects, which is intensification of corn-soybean rotation with winter wheat. So we are in Illinois. It's basically the largest soybean producer and then the second largest corn producer in the United States. And basically your corn-soybean rotation is the dominant cropping systems in the state. We are also one of the 12 states in upper Mississippi River Basin, which actively trying to reduce NMP losses through nutrient loss reduction strategy. Within that nutrient loss reduction strategy, one of the best in-field practices is basically using winter cover crops. I'm going to argue that when we talk about winter cover crops, we should focus on like cereals, much more than any other basically species, to do that job of nutrient loss reduction, especially N. This is a paper done with also the Dr. Villiers and Schoonover's lab, looking at wedge and corn rotation, and then we basically look at nitrate leaching within that system, and seeing that actually wedge, while benefited corn in terms of like yield production, increased leaching. On the other hand, this is a data from Lowell Gentry paper published in JQ that shows that having rye in the system or cereals in the system basically could reduce basically nitrate leaching. And here in this case, maybe not a statistically significant, but percent-wise meaningful reduction that we are looking for. And then another paper coming from Villiers' lab, published in Vedas and journals, kind of follow the same pattern. Not a lot of farmers would be willing maybe to do winter cereal cover crops. Some are, however, interested in doing like double crops. So especially where we are in southern Illinois, double cropping is a very common basically cropping systems in which you basically have a corn in the system followed by winter wheat and then go to soybean in rotation. The challenge for that being as a strategy to reduce nutrient losses is the N management in that winter wheat as you're fertilizing that as a cash crop. Basically, that when we talk about nitrogen management in winter wheat, based on our discussions with the growers, that's kind of like how it happens. So they're going to have like a fall applied nitrogen as an ammonium-based P fertilizers, followed by a spring N application at green up and then at jointing. So it's like a three-way split of an application. There is a paper like Andrew was talking about. So when you apply that fall DAP or fall MAP, you might lose some of it basically through leaching or denitrification. And then when you put things in that 4R N management, thinking about application timing or rate, our idea was, okay, what if we move that fall applied DAP to a spring? And then what if we reduce the rate that is suggested to see whether that would be able to make this system less leaky, basically. So the hypothesis was, if we do double cropping, we assume that we are going to be more profitable compared to a single season bean in rotation. We think that that profitability is actually related to how we manage nitrogen in that system. And then when we have basically winter wheat integrated into corn-soybean rotation, we would see potentially reduced in nitrate leaching. And also, we could potentially add more carbon to the system, build soil carbon and soil health over time. So the main objectives were to evaluate that inclusion of wheat in double cropping systems with soybean and see how would that basically relate to nitrate leaching, whether you increase it or decrease it, N management within that winter wheat, and how would that influence these losses, and then system-based, as like Lowell Gentry was talking about. If we put things into a system perspective, comparing corn with soybean as a double crop system with and without rye as a cover crop in that rotation, with just corn soybean alone, or corn rye soybean rye as like two check plots for us. So we initiated this study in 2021 in two locations, one in Carbondale, one in Belleville, Illinois. We had 8 treatments. So these are like kind of color coded, as you can see on the bottom. So CNSN, so abbreviation is like corn no cover crop, soybean no cover crop. Then it goes to corn rye, soybean rye. And then we have 6 double crop systems. So those double crop systems are color coded by blue, green, and red. The blue is when we had winter wheat that is basically managed with nitrogen, that is, we call it low intensity. The blue is when we manage the nitrogen as like medium intensity, and then basically red is high intensity. And then in the next slide, I kind of explain to you what those are. But the darker color ones are the ones that have rye in the system, lighter color ones don't. So that's kind of like how these rotations look like. When we say wheat with low intensity nitrogen management, that's when we applied a spring map at 27 nitrogen per acre, followed by UAN that applied at green up, that's 40 pounds per acre, plus jointing at 40 pounds per acre. So in total, it's like 107 pounds per acre. But then when we go to medium and basically high intensity, and medium, we still apply that map in the fall, in the spring, followed by higher nitrogen application as UAN. So those are like 70 at jointing, 70 at green up. For the high intensity, that's what like the kind of like a farmer suggested rates, which was full applied map at 27 pounds per acre, followed by 70 pounds at green up and 70 pounds at jointing. That's kind of like how the trial looked like. This is an example of like, we have pan lysimeters there, like basically leading, the lead is Dr. Williard on those. We have gas chambers to measure greenhouse gas emissions. In this case, we already had planted full season soybean in the system, and then we harvested wheat and then going to plant soybean as a double crop. And so we measured and monitored multiple things. Those include like cash crop and cover crop biomass and growth and yield, soil and dynamic, soil moisture and temperature, greenhouse gas emissions. We use basically closed vented chambers for those. And then we monitored nitrate leaching and DRP using pan lysimeters, and also soil health indicators. So we look at like soil physical, biological, and chemicals. It's like soil fertility. For physicals, that mainly I'm gonna focus on today, we look at like infiltration using that Sadeghpour unit, aggregate stability, and then carbon within aggregates and by depth. So I'm gonna jump into basically our results. I will categorize this into like crop yield, leaching, and then soil health, basically sections. So this is the crop yield. So one thing besides that, like our nitrogen management didn't really influence the grain yield of winter wheat. We had a really challenging site at ARC. Later I'll show you that the compaction of that field is pretty high. And then basically that's soil there is also poorer compared to a Belleville site that we have. So we get like a lot much better like yields at the Belleville site, but not as much in the basically ARC or Carbondale sites. When we look at soybean yields, we basically got, as expected, higher yields with single season soybean compared to double crop systems. But interestingly, at the Carbondale site, some of those soybeans in the double crop systems were comparable, like statistically comparable to the single season systems, meaning that you potentially are like economically benefiting from these, like without even doing much calculations there. This is the cereal rye following after basically cash crops. We have like in 2023, the cereal rye performed much better. In 2025, it was much more challenging, and so they didn't do as good. Like I wanted to pay attention to that ARC 2025, which we had less than 1,000 pounds per acre cereal rye biomass. But actually, later when I show you the leaching data, that does something, and like kind of like goes back to what Lowell Gentry was talking about. You need like half a ton at least to get the leaching reduction, and it actually shows that later on. I'll show you that. And then when we look at corn grain yields, we look at like average 4 side years. We didn't see any significant differences of treatment there. When you put data together, the variability is a little bit higher in 2025, which was a challenging year, and that makes everything not significant. So that's one of the first signs I was like, hey, I get a rye in rotation and I didn't lose yield. So it's similar to no cover crop. So the conclusion for the crop yields was that like winter wheat yields were similar among N treatments. Shifting basically at a starter end from fall to spring didn't impact the winter wheat production in the system. Soybean yields were generally lower in double crop treatments, but not all the time, especially that ARC. And then corn grain yields were basically similar among all treatments. And now I'm gonna show you like bunch of leaching data going from the very first year to all the way to like corn 2025. So they're gonna be like kind of the same thing. They're all scale at 100, so it's like 0 to 100 pounds per acre. I did that so that you could follow how, which basically phase of a rotation is truly influencing or basically resulting in more leaching in the system compared to the others. So some of them could look really weird, but you see like nothing's really happening there. So this is the first year that we planted winter wheat and then we fertilized. You can see that actually having, especially in that medium and high fertilization rates, we had higher basically leaching at 57% and then 32% in that lower rate compared to a control. So that the very first year that we did it, actually it increased leaching. And then nothing really happened in that soybean season that followed. It's like almost like not contributing to the leaching losses within these whole rotation systems. When we look at basically the following fallow systems, and then when we had rye after or soybean, we saw again very low leaching losses, and those numbers, because if they're scaled at 100, they look really low. But we're talking about like 3-fold reduction by having rye in the system, for example, compared to a no rye in rotation. So rye is really doing something in terms of like reducing losses. Then we went to corn, so that's corn 2023. When we basically look at our data, you can see that almost all of them are the same, except this basically CWR SR1, so that's low winter wheat in that rotation. That was significantly lower than some of those treatments, including the one that we had as like a check corn-soybean rotation with no cover crop. That followed by our second year of winter wheat. So that's the second year we planted winter wheat in the system. And this one, the treatment differences were a lot more variable. And the treatments with rye generally are showing their benefits in the rotational scheme compared to having basically fallow treatments with no rye in the rotation. Again, in soybean 2024, we didn't see much of the leaching losses, and they're like very negligible. But when we went to that fallow period in 24, 25, and that's the one that I told you, remember those low, less than 1,000, basically pounds of CRI in that basically biomass. That's where you can see actually the reductions were very meaningful. Whenever you had rye in that system, whether you were a double crop system or continuous rye in that corn-soybean rotation, you saw a significant reduction in losses. And this is the corn in 2020 fund, which was a crazy year. So that's like the most valuable like data that we have. It's like sometimes harder to explain. But you can see like the ones that had rye in the system actually are showing a slightly higher losses. Unlike what I expected, I think that low biomass that we had with low C/N ratio that it probably had is pumping some N later into corn that might cause this slightly increase in losses of basically and leaching losses in those treatments in the corn phase. And this is like the whole like rotation all together. Like somewhat what we found is it's comparable to what Lowell Gentry's paper is showing. Like, but so we have higher basically leaching with that no cover crop treatment, that fallow like basically white bar. It reduced by having rye in rotation. The highest reduction that we saw is that double crop, basically wheat with beans at like a low end treatments. And then both of those double crop at medium and high intensity wheat with rye could reduce basically N losses by 9% compared to a fallow treatment. So whether you had rye or but you basically reduced the leaching by 20%. When you had the basically double crop at lower N rate with rye, you reduce it actually by 46%. And then the other ones are like 9%. If you just do double crop alone with no rye in rotation, that actually increased leaching losses compared to a fallow treatment. So the conclusions for this basically section was that most of the N losses occurred during that corn and winter wheat seasons. Those are the ones that we fertilize, so it makes sense to see those. Basically that the low CRI in 2024 resulted in higher and variable N losses during the following corn that got potentially some release of N from that CRI decomposed into that corn season. And then when we had that the basically double crop system with low N management plus rye, or if we have like a rye in the system, we have the most effective strategy for reducing leaching losses. If we just do double cropping alone, it might not decrease N losses in the system. And then we wanted to look at whether these 4 years change soil. So we looked at aggregate stability, for example, as one of the measurements that show up fairly reasonably quicker. And we can see that if we have basically double crop systems in rotation with and without rye, you are seeing some improvement. And that's, so the figure A is the aggregate fraction sizes of 0.25 to 2 millimeter. The figure B is aggregate, larger aggregate fraction sizes. Those are 2 to 4.75 sizes. Both kind of following the same thing. Those are, you see that improvement in your soil, especially compared to the fallow treatment. Then we look at bulk density. That's one of the reasons I told you we're not getting as much yield that we hoped we would get in the ARC side. Look at the bulk density of that field. Like it's the minimum is 1.45 gram per centimeter, cubic centimeter. And then it goes to even 1.50. Those are like restricting soils for roots. And so it's like a lot more challenging to deal with. Also not like a high organic matter soil either. And then we look at saturated hydraulic conductivity, kind of like show you how the infiltration look like. That's a very variable, basically measurement, so it didn't really pick up differences. It kind of followed the trend of like bulk density being the lowest in that CWSN, and that one having the highest infiltration. So it's gonna make sense, but it's just so variable that doesn't pick up the basically treatment differences. And then we looked at soil carbon and nitrogen within aggregates. These are like dry aggregate sizes, basically. And then we can see that, especially in double crop systems that had rye, or any of those double crop or rye cover cropping systems, you're seeing improvement in carbon within some of the smaller aggregates or larger aggregates, and the same with nitrogen. So within that 0 to 6 inch basically measurements, you're seeing improvement in carbon. It's slow, but it's happening. And that's the carbon by depth. So that goes to 36 inches. Most of the improvement that we saw was only in 0 to 2 inches. So you see an improvement in basically having cover crops, like basically that CR-SR system, and or double crop that has rye in rotation, starting to separate in carbon at the topsoil compared to a basically fallow treatment. That resulted in calculating carbon stocks of 0 to 6 inches being significantly higher in those two treatments compared to a double crop with no rye or basically fallow treatments. When we look at the whole profile soil, meaning we have carbon concentration for different depths all the way to 36 inches and bulk density within those depths, and put the whole carbon stock together, we did not see any significant differences between this treatment within just a 4-year period. So we think that the double cropping and cover cropping both improved soil, even if it was a 4-year period. Both C and N within aggregates were increased under rye or double crop with rye system. When we look at the topsoil, carbon percent was increasing with having those two treatments, resulting in like increased basically carbon stocks within 0 to 6 inches, but not within the whole profile depth. I think if we once this is run for maybe a longer time, you will start seeing those differences becoming visible. With that, I would like to thank NREC for funding this project. I would like to thank all the people involved in it, multiple graduate students and multiple collaborators. And thanks for your attention.